Welcome to video number 2 for Math 1301 for this Monday, November 24th lecture, which we're doing online. And so each semester, every class is supposed to do an online class at least one time during the semester. I haven't done one yet. I think we're supposed to do it a little bit earlier in the semester, so I apologize for that. But it does work out well. It's a Thanksgiving week, so it might allow you to flex a bit with your schedule. What we're going to do now is we're going to look at section 7.4, which is a section on dimensional analysis. Dimensional analysis is something that most individuals who've taken some chemistry, most individuals will be familiar with in the chemistry world, because molarity and molality both use this dimensional analysis. You might have a situation where you want to know the number of atoms or the number of molecules in a particular mass, and you do some conversion with that. There's all kinds of dimensional analysis where maybe you want to know the atomic weight of something, and there's some dimensional analysis maybe with that. And so, but in our situation, when we're talking about conversion from English to metric or metric to English, it works out something like this. Now, I'm going to do an example just within the English system. And so, for instance, dimensional analysis, you might have something like this: 5 yards, and we want to know, well, how many inches are in 5 yards? We want to know. That's what we're looking for. And so what we need to do is we're going to need to do some multiplying, dividing in order to get this converted properly. Now, in dimensional analysis, we're used to fractions where we divide one number by another. 10 divided by 5 is equal to 2. But in this case, we're not just dividing the numbers, we're also dividing the units of measure. And so in this case, we know that there are 3 feet to 1 yard, and that there are 12 inches in 1 foot. And the reason I'm emphasizing not just the numbers, but the units of measure, is what dimensional analysis teaches is this idea that you can cancel not just simplify the fraction, but you can cancel the units of measure. And so here we have the yards go away, the feet go away, and all that's left are inches, which is what we want down there. So 5 times 3 times 12, and we find out this is 180 inches. And so this is called dimensional analysis. Now let me give you an example like it. This is an example where we have, we want to get how many cups. Here we are at Thanksgiving week. You might be doing some cooking. So here we go. How many cups? So the question is, how many cups are there in 2 gallons? Now, I don't know what you're making for Thanksgiving that you need 2 gallons of something, but maybe it's fruit salad or something. I don't know. You're going to make 2 gallons for the 40 people coming to your house. So in this case, we start with 2 gallons. And over here, we want how many cups. We want to know how many cups are in 2 gallons. So we're looking for this. Now, let's suppose we don't know how many cups are in a gallon, but we do know how many quarts are in a gallon. So we do that there are 4 quarts in 1 gallon. And then we discover that there are 4 cups in 1 quart. And here again is the dimensional analysis idea. This is where not only are we messing with these fractions on the numerical side, but we're also working with the units of measure. Gallons cancel, quarts cancel, and what we're left with is the cups. So 2 times 4 times 4, and so we have 32 cups are in these 2 gallons. And the reason for doing dimensional analysis like this is it will make sure or ensure that at the end we have the right result, because not only do we have numbers here, but we have to get rid of gallons and get rid of quarts so we can get to the cups. And so that's how you do this. So here we wanted to get rid of the yards so we could get to the inches. And the way we did that is not only multiply 5 times 3 times 12, but we simplified this fraction by canceling out these. And this will help because notice there would be a temptation to maybe get this confused and write this as 1 yard to 3 feet. But what would happen is you would get yards squared and the feet wouldn't cancel with anything. And this is how you know you've done it properly, is that these things should be canceling as you move this way. So if you accidentally wrote this upside down, 1 gallon to 4 quarts, you would discover that this won't work because the units of measure now won't match to be able to cancel. And so this is what dimensional analysis is about, is setting up these fractions so that not only do the numbers work out when you multiply and divide, but that the units of measure end with the results you're looking for. And so this is called dimensional analysis. And so what we're going to do now is we're going to work a few problems along this vein. So for instance, that leads to the second clue. You need to send me 2 clues from these videos so that I know that you've watched the 2 videos. So if you'll email me, there's some bonus points on your next test for simply emailing me. And in this case, the thing I'd like for you to email me is that the color of my shirt is purple. And so that's the second clue. From the first video, I gave you a clue. This video, the clue is purple. If you'll email those 2 clues to my email address on Blackboard, I will add bonus points to your next exam. So that way I know for sure you watched the videos. All right, so number 12 in the book, these are slightly simpler problems because there's not 2 things of conversion, just really 1. And they come from the table in the section. There's a conversion table in the section. And on the test, you'll of course be given these conversion tables. I wouldn't have you memorize them. But you must be careful about one thing. There's multiple tables. And some of the tables convert from length to length. Some convert from area to area, and some from volume to volume. And you have to be careful to make sure that if you're being asked an area question of conversion, you don't look at the table for the length. And if you're looking for volume, you can't look in the area section. You have to make sure you're in the right area. So if it asks you to convert from a unit of measure in volume to a unit of measure in volume, you have to make sure you're in that part of the conversion table or you're going to get it wrong. Now, the first one's a unit of measure. Number 12 asks for 90 inches to centimeters. All right, and so just using very simple dimensional analysis, we find out in the table that in 1 inch, there is 2.54 centimeters. So the conversion here for 90 inches, we're going to multiply by, so that at the end we have centimeters. So what we need is, we need inches to get canceled, and we need centimeters left. You see that? So that the inches will cancel, and that means we're going to write 1 inch and 2.54 centimeters. You see what will happen is those 2 will cancel. And what will be left is the inches are canceling out, leaving me centimeters. And this will give us 228.6 centimeters. Now, this is important because if we got this confused and wrote this as inches over centimeters, you would get inches squared over centimeters. And that's clearly not the unit of measure we're looking for. So that's how the dimensional analysis is supposed to help us not get confused. All right, so number 14, let's see, it looks like we have 9.6 meters, and we want to convert that to yards. So this time, up here we went from the English system to the metric system. Here we're going the metric to the English. So we do 9.6 meters. Oh, we got to look up the table. And if we look up the table, we'll find that 1 yard is equal to about 0.9 meters. I don't think that's exact, but it's what we're going to use. And so this times 1 yard divided by 0.9 meters. Now the reason we want to be so careful with this is that you'll see this time we're not multiplying, but we're dividing. The meters will cancel, and we'll be left with yards. So 9.6 divided by 0.9 is 10.67 yards. And so there's an example of dimensional analysis Where in this case, so far, the 3 that we did previously, we multiplied. We didn't divide. But here's a case where we're actually dividing because we have yards in the numerator and meters in the denominator. So the meters will cancel, but we have to divide 9.6 by 0.9. You're going to use your calculator, and you'll get 10.67. All right, here's one more example here. This is number 16. And number 16, we have 20 yards squared. And we want to convert this to square meters. Now, here's the temptation, is to use this as your conversion, but that will not work. You've got to look in the area section of the table. And so when you look in the area section of the table, you're going to find that 1 yard squared is actually equal to 0.8 meters squared. And so now we do 20 yards squared times, and now we have the meters. We want meters squared is our solution. So we got to divide by yards squared. So we're going to write the 1 here and the 0.8 there. And that will give us 16 meters squared. And you see in the dimensional analysis that the yards square cancel. And this is why dimensional analysis is so important. That way we don't write accidentally 0.8 and 1, because if we did that, we would wind up with yards to the 4th divided by meters squared, a completely meaningless unit of measure. And we would then realize, oh, we've made a mistake. These yards squared need to cancel. So I've got to get the fraction so that those will cancel, so that what's left is this meter squared here. This is how dimensional analysis can be so helpful in the area of converting from units of measure in the metric system to units of measure in the English system. Now, along those lines, you can use it to convert all kinds of things, including getting the measurement for how many cups or pints you need in order to make whatever dessert you're going to bake for your Thanksgiving meal. So these kinds of dimensional analysis work out well. If you have a measuring cup, but you do not have a measuring spoon, and you need to convert teaspoons into cups or pints or something like that, this is where you might do a little dimensional analysis. Of course, knowing you guys, you would simply ask Siri to help you, and that would take care of it. All right, so number 20, this is one that's a little different. This is conversion of 253 ounces to grams. Now, one of the major problems in the realm of the English system is there are ounces that have to do with weight or mass, and in this case, that's weight. This is mass, but again, the standard measurement of gravity makes it to where we can talk about them interchangeably. But in the English system, there are ounces in the world of mass and weight, and then there are ounces that are known as fluid ounces. It's really confusing because, as far as I can tell, these are not related to one another. So there you have it. That's not helpful. The Brits didn't help us out, and America didn't help by embracing the Brits in that regard. We had the revolution. We should have revolted against also the English measurement system. But we got rid of the king, but kept the measurement of foot, the feet and yards, miles. Yeah, it's unfortunate. All right, so we have 1 ounce is equal to 28 grams. And so we're going to now do dimensional analysis. We have 253 ounces. So we always write this first measure down. And then out here, we're going to write, what do we want our final unit of measure to be? The answer is in grams. So we're going to multiply this by ounces down here and grams up here. And again, we'll find 1 ounce is 28 grams. So the ounces will cancel, and this will leave us with 7,084 grams. All right, and that leads to one final example here. This is number 24 in that section, and this is a measurement of volume, 25.6 milliliters, and we want to convert that to fluid ounces. Whoops. ounces. And so we need to know that 1 fluid ounce is equal to 30 milliliters. All right, so we have, we're going to start with this number, 25.6 milliliters. And we want over here in the final analysis here is fluid ounces. So we're going to multiply by fluid ounces and divide by milliliters. And so this is, we have 30 milliliters to 1 fluid ounce. And we see when we do this that the milliliters will cancel in the dimensional analysis, and this will then equal 0.853 fluid ounces. And so this is how dimensional analysis allows us to use those tables safely and make sure that the conversion we're doing makes sense. And so this is the way of doing that. You compare, ounces to ounces, grams, so forth. We started with ounces. We want grams. We know that 1 ounce equals 28 grams, and therefore dimensional analysis allows us to do this. And so that's a way in which dimensional analysis allows us to maybe error-proof ourselves from converting inappropriately. So if we were to flip these, we would get ounces squared over grams, a completely meaningless unit of measure. And so by using dimensional analysis, we make sure we know, are we multiplying or dividing? How do we know? Well, I need the ounces to cancel. I need grams left over. Here's the conversion. I write them where they go. 1 ounce there, 28 grams there. I'm multiplying. The ounces will cancel out. The reverse happens here. I'm looking for fluid ounces. I'm starting with milliliters, looking for fluid ounces. I need the milliliters to cancel out. I need fluid ounces to be in the numerator. I need milliliters in the denominator. So now I look over here and I get 1 fluid ounce. I'm going to put the 1 there. I need 30 milliliters. I'm going to put the 30 there. Now I'm dividing. You see, because in dimensional analysis, the milliliters will cancel, leaving me fluid ounces. And this gives me a number that is divided by 30, 25.6 divided by 30, 0.853. And so dimensional analysis is a protection to make sure that we convert correctly as we convert from either metric to English or English to metric, or even with inside one of those systems, I'm going to go from meters to some other measure within the metric system. Even then, I might use dimensional analysis to make that conversion. And so that's our lecture for this November 24th. God bless you guys. I hope you have a great Thanksgiving. I will see you the Monday a week from now in class.